So IonQ's scaling strategy was defined early on. That scaling strategy is premised on the fact that in a trapped ion system, the trapped ions have a natural inherent high fidelity. It's one of the modalities that has the best overall fidelity right out of the box.
And trapped ions are great first and foremost because they're ions. Ions are atoms, and all of the atoms are the same from nature. So that's very powerful because they are not subject to manufacturing variability, which means that we can build and engineer these systems with incredible precision and kind of staggering scale. And really getting into that stage of doing quantum computer engineering is very exciting.
High fidelity long chain operation at some point reaches a limit, at which point you need to be able to break those chains into multiple cores. That's the second piece of our scaling strategy, being able to operate multiple cores of long chains at high fidelity to be able to drive overall increased circuit depth and overall performance. This is our reconfigurable multi-core quantum architecture. At some point, you reach a limit of what a single multi-core system can do, at which point you then move to multi-QPU. That's done through photonically interconnected systems. It's something that was demonstrated in the lab years ago. We're now in the process of commercializing that technology. And so part of our scaling strategy is our photonically interconnected systems, or our photonic interconnects. Photonic interconnects is based off of the fundamental principle that you can entangle an ion with a photon. In our Seattle facility, we're building systems to be able to do these demonstrations, be able to scale these technologies. Part of the work that we're doing in Seattle is associated with some of our Air Force contracts. Some of that networking work is building on and trying to deliver overall components of our photonically interconnected kind of technology roadmap for the Air Force.
So in summary, the main feature of our architecture that enables scaling is flexible and complete connectivity within the core, the ability to chain these cores together and reconfigure them, and the capability of trapped ions to be interconnected photonically. And so overall, you have these three tiers of scaling: parcels or cores, out to modules, and out to interconnected modules. And in doing this, and doing this in a balanced way, we can have an incredibly flexible architecture for scaling towards larger and larger algorithms, and be agnostic to what the particular structure of those algorithms are. Because, we aren't on this journey alone. And as we start to build better and better hardware, it's our sincere hope that our customers are going to come up with applications that we haven't even thought of.